Hey, geometry kids. We're jumping right into chapter 12 now. This is usually the second chapter that I do out of the book, just because we did a little bit of probability in chapter 0, and so kind of going along with that, chapter 12 was all about probability. So I went ahead and put the assignment up here at the top. It's out of the book. We're all the way at the back of the book since we're in chapter 12, so page 862, which seems like all the way through, and it kind of is. So 6 through 24 the evens, 32 through 36 the evens, and just one-sided page today for notes. So 12.1 starts us off with probability by just talking about sample space and just getting us set up for just the basics of probability. So sample space is the set of all possible outcomes. Okay, so like let's say I'm tossing a coin. Okay, the sample space for tossing a coin would just be heads and tails, and I do that little ugly squiggly bracket. Okay, that's a list of the sample space for tossing a coin. We also have like rolling a dice. Just one dice would be the numbers 1, 2, 3, 4, 5, or 6. That's examples of what like a sample space would be. It's just the list of possible outcomes that you could get. Okay, so example 1 now, they take that a step further where they're talking about tossing a coin twice. And represent the sample space for this experiment by making an organized list, a table, and a tree diagram. So 3 things. This right here, what I did was an organized list. So I'm going to do the same thing, but now we're going to do it for tossing 2 coins. So for tossing 2 coins, I could get a head, I could get a head tail, I could get a tail head, or I could get a tail. And those are my 4 possible outcomes that I could get. Okay, if I list them in a table format, so it's going to look kind of like this a little bit. Okay, let's say like this is my first toss. I could toss a heads or a tails, and my second toss, I could toss a heads or a tails, right? So in this spot would be like heads, because that's where that lines up. So heads. This spot would be tails, heads, because we're doing tails first. So tails, heads. This would be heads, tails, and this would be tails. I hope that box kind of made sense, but it's like, where they cross each other, I guess. And then the last thing is a tree diagram. So let me zoom in on this guy. I'll leave the little box up so if you're still copying that down. Let's say like this is my first toss, right? I could toss a heads or a tails. And then from there, after I've tossed, let's say a heads, this is my second toss. I could toss a heads or a tails. Or let's say I tossed a tails first, and this is my second toss, then I could toss a heads or a tails. So you can kind of see from this tree diagram that heads is one option. Let me go to a different color. Heads is an option, heads tails is an option, tails heads, and tails is an option. So it's just kind of going along the branches there. Okay? All right, now let's talk about real quick how, because sometimes it's hard to know how many outcomes you have in a list. And so like here I know there was 4, but how do you know that there's 4? Well, if I'm tossing a coin twice, there's 2 outcomes for the first toss, there's 2 outcomes for the second toss, and I multiply those together, and that means that there's 4 total combinations that are going to be in my sample space. Okay, if I was tossing a coin 3 times, I'm giving you lots of extra information. Tossing a coin 3 times would be 2 times 2 times 2, which is actually 8 combinations. Okay, so that would be like heads, 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 tails, etc., all the way down, right? So 8 combinations for that one because 2 times 2 times 2. So that can kind of help you if you're making a list or things like that to know how many there are so you don't forget one. Okay. All right. Example 2, multi-stage tree diagram. So this is going to be a massive tree diagram. Be prepared to write really small. Okay. To take a hamburger order, Keandra asks each customer the following questions. Draw a tree diagram to represent the sample space for hamburger orders. Blah. Okay, here we go. What size burger is the first thing that they have to decide? So we have a kids, regular, large, and I'm going to abbreviate some stuff. So I'm going to go here, I'm going to go all the way over here, and I'm going to go all the way over here. So we have a kids, we have a regular, and we have a large. There we go. Okay, those are my 3 options. Check, he's done. Okay, would you like cheese? So let's say they order a kids burger. Okay, they have to decide, and I'm going to make this rather large because these branches need to be big. We have cheese, or the other option is no cheese, right? Okay, regular burger, cheese or no cheese. And then large, we have cheese or no cheese on our burger. Okay, and then we have tomato. I'm going to go back to red. Tomato, no tomato. 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 This is going to get really tedious. And some of you guys are bored already. Tomato, no tomato. There you go. Okay. And then pickles. Last step. Pickle, no pickle. Pickle, no pickle. Pickle, no pickle. You get the idea, right? Pickle, no pickle. 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 Blah, 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 blah. All the way through. Holy cow. Okay, so I'm not going to fill the rest of those out, but you guys can see like how that all works, okay? So there's that. So let's say I am ordering a burger, and I'm going to order a regular burger with cheese, with tomato, no pickle. That's going to be one combination, okay, of order that I could have. Maybe you instead want a kid's burger with no cheese, but yes tomato and yes pickle, right? That would be another order that you could complete, right? So, how many orders total could there be? So here's this deal. The bottom branch of your tree diagram, the number of options that there are there will tell you how many different choices or options or burgers could be made, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 different options for burgers that I can make, okay? Now, how do I get to that faster? Well, there are 3 different kinds of burgers. Check. There are 2 options for cheese, which are cheese and no cheese. There are 2 options for tomato or no tomato, and there's 2 options for pickle or no pickle. And if I multiply those guys together, just like I did up above, I get 24. So 24 different combinations. That way I know I did not forget any of them. Okay, that is a massive tree diagram. Holy cow. I don't think your homework assignment makes you do any of them that are quite that large. Okay. Fundamental counting principle, we've already actually done this. The fundamental counting principle says the number of possible outcomes can be found by multiplying the number of possible outcomes from each stage of the event. So just what we did here. We literally used the fundamental counting principle there. We did it here. We did it here also to find the number of options that we have total, okay? So example 3 is not going to ask us to draw a tree diagram or anything like that. They're just going to say how many ways can I, how many options are there for different rings, okay? So here's what we have going on here. They're talking about class rings here, and they're saying that there's 10 different choices for metals, okay? Like silver, gold, titanium, whatever. There are 2 different kinds of finishes, 12 stone colors, 5 cuts, and then there's activity logos. So you can have like a volleyball on one side, or you can have like a BH on one side, or a National Honor Society on one side, whatever. And then you have 20 different activity logos that could go on the other side, okay? And then band style, maybe it's like a wide band versus a narrow band, something like that, right? So there's all of those things, okay? Haley has selected an overall style for her class ring, and now she must choose from the ring options shown. How many different rings could Haley create in her chosen size and style? This is going to be massive. So we would just literally take all of these times each other. 10 times 2 times 12 times 5 times 20 times 20 times 2 again. Holy crap, that's a lot. Okay, I don't even have a calculator with me, so I can't even calculate that out. I can multiply some of these together. So like I know 10 times 2 is 20. I know 12 times 5 is 60. I know 20 times 20 is 400, but then that times 2 is 800. Hey, I might be able to get to this answer. 60 times 80 is 48 with 3 zeros, and then times 20 is 9 6 with 1, 2, 3, 4 zeros. Check that and make sure that that's right. Use your calculator, check that to make sure that's right. That means that there are 906. She's already chosen a style. Like, that doesn't even include the different styles that you could have, right? She's already chosen a style. But even after that, there's 960 different rings that you can choose. Holy cow. So the chances of you and somebody else picking randomly the exact same ring are really, really slim to none. 960,000. Holy cow. Okay. Part B, last one. Is this the last one? Yeah. Last one. The answer sheet shown is completed. How many possible outcomes are there? Okay. So here's my answer sheet. I have 10 questions on this answer sheet. And let's say I randomly pick B, and then C, and then A, and then B, and then D, and then C, and then true, true, false, true. That is one way of filling the answer sheet out of how many total, like total different ways I could fill out the answer sheet, right? So when we're doing this, we look at like how many different choices I have, right? So number 1 has 4 different options. Same thing for number 2 and number 3 and number 4 and number 5 and number 6. They each have 4 different options, right? And then 7, 8, 9, and 10, they each have 2 different options, right? Okay, so I would do like 4 times 4 times 4 times 4 times 4 times 4 times 2 times 2 times 2. Now, and before you go typing that into your calculator, one thing that you could do instead to save time is there are 6 of these 4s. You could do 4 to the 6th power times 2 to the 4th power, right? There are 6 different questions that have 4 answer choices and 4 different questions that have 2 answer choices. That is a really big number again, and I'm not going to even try to attempt to get that answer, but it's going to be a decent sized number. Figure out what that is on your calculator and do that, and that is like this number is telling you the number of possible ways of filling out that answer sheet, okay? Which is a lot. Like there's many different combinations, because even if I wanted to do a different combination, I could leave all of these the same, except I could switch this from B to A, and that would be an entirely new combination, right? But I only switched one answer choice, right? So there's going to be quite a few different ways of filling this answer sheet out, okay? And that's all by using the fundamental counting principle. We figure out the number of ways of doing that by, multiplying the options together. Okay, I'm going to do one more example. Don't kill me. Here we go. Example, let's do like, because they like to pick on these a lot. They will say something like how many passwords can be created. So let's say like you have your lunch number, right? And let's say that I'm going to say how many lunch numbers can be created. How many lunch numbers, okay? And I'm going to say with repeats, and I'm going to say without repeats, okay? And here's what I mean by that, all right? So you have a lunch number, right? Okay, how many lunch numbers can you create if you are allowed to repeat those numbers? So like, let's say I have the lunch number 7476, right? The 7 is allowed to repeat, or any of the numbers are allowed to repeat again, okay? So to figure this out, we ask like how many different numbers could go in that spot, okay? Now you have to take into account that 0 can go in that spot. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is actually 10 different numbers that could go in that spot, okay? And then given that number's chosen, we can have 10 numbers in this spot and 10 numbers in this spot and 10 numbers in this spot, because any of those numbers could repeat again. So if I multiply those together, that is 10,000 different lunch numbers that could be created, okay, with any digits, all right? If I limit that though, and I say, okay, we cannot repeat those numbers, now this can't be 7476 again. This has to be like 7456 or something like that, right? So there are 10 numbers that could go in this first spot, but after the 7 is chosen, we cannot use a 7 again, which means there's only 9 numbers that could be chosen, okay? After we choose this as a 4, we can't use a 7 or a 4 again, so there's only 8 options. Then we can't use a 7, a 4, or a 5, so there's only 7 options, and we would multiply those together. Okay, 10 times 9 times 8 times 7, whatever that is, okay? And it's going to be a number that is smaller than 10,000 because we're limiting down the numbers. I don't know, it's like, I want to say it's like 5040, but don't quote me on that. 5040. I know we've done that problem before. I think I did it last week with my algebra kids. So don't quote me on that. I don't know for sure, but it might be 5040. So it almost cuts our number of options in half by limiting that we can't have repeats. Okay, so that's an example of a fundamental counting principle again. All right, so use the rest of the time in class to work on that homework assignment, and that's all I have for today.